I see some names on the attendee list that I recognize, which is nice. I hope it's a friendly audience.
And you know that usually too, what is so nice, we put it up in the web, and I heard many comments, people going after and listening.
Oh yes.
And people say, "Oh, I loved it." So our the gallery, it's like, yeah, it was great. People
That's wonderful. Back, so. Yeah, because not everybody is free at a given time.
Exactly, so and we put it, yeah.
I frequently listen to recordings myself.
Yeah. And it's super informative. Hey, I have my coffee.
I have my water.
That is great, yeah.
I OD'd on my green tea this morning. I don't need any more.
I moved my office. I had an office for 10 years away from my students, and the group grew, and I wanted to be close to them. So I moved. So it's so nice.
And you're loving it.
See them. Oh, I'm loving seeing them, and the postdocs.
What building are you in?
I am in the CIS building. Okay, let me start. So welcome everybody. We have the immense pleasure of having MAURA Hagan talk to us. And I met MAURA in many committees, and it was such a pleasure. And she was one of my mentors, the people that I looked up when I entered in space physics. So it's an incredible honor to have her. She is recognized for the work of dynamic coupling in the Earth atmosphere, the role of global scale waves, known as solar atmospheric tides. I'm not going to tell you all about her career because this is part, I don't want to, steal the thunder from her story. But she is a current position Dean of the College of Science and Professor of Physics in Utah. She's now an emeritus, and she's also part of the National Academy of Science. She has many recognitions. So I am just going to share my screen and tell you a little bit what is a SHIELD webinar about. So let me just put it in full screen here. So SHIELD is one of the funded NASA drive centers. And before I start telling you what SHIELD is about, if you're not familiar with, I like to play this movie that tell you, or at least motivate you, why you would like to study heliospheric science. So if you look on the planets away from the sun, and you zoom out, the heliosphere is our home in the galaxy. And we're actually still debating the shape of it. Here I'm showing one of the shapes of a croissant shape, but this is one of boundaries that separate us from the galaxy. And we think it has to do with the development of life on Earth. So we would like to understand the properties of this boundary, the heliosphere. And the other piece that at least get me excited in the morning is that when you look up in the sky and you see stars, you know that every single star has an astrosphere. It has an envelope around it. So whatever we're going to learn about the heliosphere and its properties, we're learning about every other single star that have wings. Some are massive, so you can see the cocoons around them, but some are like the sun, very rarefied, and it's really hard to see. But you see the bright star, but it's actually enveloped in a cocoon. And in particularly, we're interested in the properties of this cocoon for habitability. And we have one data point that is ours. We know there is life on Earth. And we would like to also understand the relationship of the properties of the heliosphere to the development of life. So these are cases of many other astrospheres, MIRA, and here you can see, and they come in different shapes and flavors. And today we have the immense pleasure of having MAURA talk to us. SHIELD webinar is part of the broader impact of the center, and SHIELD stand, the acronym is Solar Wind with Hydrogen Ion Charge Exchange and Large Scale Dynamics. You can check our website of all the activities that we have. But the goal of the center is to have a twin analog of the heliosphere to really understand the nature of the structure of the heliosphere and be able to predict its properties, not just even now, but in the past or in the future of as the sun traversing the galaxy. And as you can see in this mosaic, the heliosphere has lots of phenomena that we are not understanding or that are not incorporating in models, like small scale stuff like turbulence, reconnection, instabilities. And we have observations both from in situ satellites like New Horizons and Voyager, but also from remote that give us an image of the heliosphere from energetic neutral atoms, from IBEX, Cassini, and future IMAP. So we're trying to put with SHIELD all these different data set together to try to understand the heliosphere. And we have 4 different questions. I'm not going to go through them, but there are major existential questions that we're still not understanding the nature and the structure of the heliosphere. SHIELD houses many institutions that are shown here. It's a collaboration of more than 40 different scientists. And one of the arms of SHIELD is not just a science, but to broaden the participation of underrepresented groups. So we have many different activities that span from undergrad to grad to young researchers to faculties with different activities that we do. And very close to my heart is its SHIELD webinars, when we bring people like MAURA to discuss in a very unguarded way, how was the trajectory, how you got your mentors, who did you look up as you develop your career, to try to inspire younger researchers and other people coming into the field that are trying to chart their way in a field that sometimes is not that diverse. We also have something called testimonials. We're going to relaunch it now in this year. So we are going to be calling up for you guys for younger voices to come and record part of your trajectory, again, as this idea that you can be what you can see. We would like a mosaic of faces and testimonials, first-generation scientists, immigrant experience, and so forth, that people come in, look, and say, I can also be a space scientist. And our next event will be a webinar in April 21 with Linda Elkins-Tantor. She is the PI on Psyche mission. We also have a coffee chat, very active, when people like myself and other PIs are not invited, what I think is great. They have a safe space to debate issues about career, science. Now they're talking about writing a research statement. And the next one will be next week, March 24. So I think I'm going to stop here. If you have any questions and interest in participating, please email us at shieldoutreach@bu.edu. And I'm going to give the floor to MAURA.
Marav, before you move on, I'm sorry, the date, we didn't change the date on the next SHIELD webinar. It's in May. It's May 19th.
Oh, okay. Thank you for the correction. Okay, great. MAURA, floor is yours.
Well, thanks so much, Marav. I really appreciate the invitation and the opportunity to tell my story. Let's see, I'm trying to go into presentation mode here. Can you see my screen, everybody?
Yes.
Okay, super. Okay, so as Marav suggested, I'm not going to be giving a science talk today. I'm going to tell you about my story, my career path. So those of you who are online hoping to hear about science, you can sign off now. Anyway, I subtitled my talk, How a Little Girl Who Was Good at Math Discovered a Career in Space Physics, because just as Marav suggested, you can't be what you can't see. And I had no idea about what a space physics career even was when I was young. So who am I? Well, I was born and raised and educated and spent my entire career living and working in the United States. I'm an American space physicist. And I was born in Massachusetts, not very far from where Marav is sitting today. And I lived in the Boston suburbs until I was 8 years old when I moved to New Hampshire. And so I say that I grew up in New Hampshire because that's where I remember growing up. I don't have a great memory of my earliest years. I'm the oldest of 7 children. My father was a businessman. He worked for the phone company. And he was the first in his family to go to college. He was a World War II veteran, a Navy, enlisted Navy man. He enlisted when he was 17 years old before he even graduated high school. And so he went to school on the GI Bill. And my mother was a homemaker, and she is a first generation Irish American. Her mother and dad actually met on the boat when they were emigrating to the United States. And so for those of you who don't know, today is St. Patrick's Day, and those of us with Irish heritage celebrate that and celebrate those who went before us and made our opportunities possible. And so I have an Irish blessing to bestow on all of you online, and that is, may your joys be as deep as the oceans, your troubles as light as its foam, and may you find sweet peace of mind wherever you may roam.
Beautiful.
Happy St. Patrick's Day from me.
Beautiful.
So my earliest role model was actually my mother's sister. And her name was Mary Elizabeth Walsh, and she married a man named Edward Flynn. And I am actually her namesake. So my name is MAURA Elizabeth, and MAURA is the anglicized version of the Irish for Mary. You may know people by the name of Maureen. Anything with an "een" on the end of it is little. So Maureen is a little Mary, a Housheen is a little house in the back of the yard, and a Colleen is a little girl, and so forth. So anyway, I'm her namesake. She was my godmother, and she was a first generation college student. So her mom and dad were not educated. They were literate, but they weren't educated. And so it was quite an achievement for her to go to college. And she actually graduated from Emmanuel College, and that name will appear later in my talk. She had a master's degree in library science from Simmons College, also in Boston. And she was the head librarian for the state of Massachusetts. She was a wonderful person and very good to me. So the other thing that I wanted to mention is that I was profoundly moved by the Apollo program. So I was a tween and a young teenager when we landed on the moon. And so we used to spend summers on Cape Cod. My parents would rent a house, and we would spend the summer there for a month or so. And the year that we landed on the moon in 1969, oh geez, I'm sorry, my bad.
I didn't know you were a twin. I'm a twin too. That is great.
No, I wasn't a twin. A tween meaning that I was in my
got it.
Before teenager and
got it.
Yeah. Anyway, in 1969, my mother could not get me to go to the beach because I was glued to the television. The television coverage of the Apollo program was pretty much 24/7, and so I must have had an inkling that I wanted to be a space physicist even before I did. I didn't want to be an astronaut, but I was intrigued by space physics. So the next thing I'd like to share with you is that I actually went to Emmanuel College, which was at the time an all-women's school. And Emmanuel is in Boston in Back Bay. It's on the Fenway, not too far from Fenway Park. And I loved being in school there. And but I thought I was going to be a math major. I was good at math, and I liked it. And when I started as a math major, I became really disenfranchised with it. I was a little bored, to tell you the truth. My academic advisor happened to be Professor Ronald O'Brien, and he's pictured here on the right side of the frame. And Dr. O'Brien suggested that I take a physics course, that I would like physics because it used math, but it was more than math. And I said, physics? I hate physics. And I thought I hated physics because I had a teacher in high school who was all about the notebook and the tidiness, and it wasn't at all enjoyable to learn physics. But he said, well, why don't you give it a shot? You might like it. And so I did, and of course I loved it. And in particular, Camille Menachino, who is the person who's pictured in the left side of the screen talking to a couple of students. And I should tell you that the woman in the back here, in the upper part of the right-hand side, is a very dear friend of mine to this day. That's Maureen Kelly. And but Camille was wonderful. She made physics very exciting, and we talked about the philosophy of physics. We just really had a blast, and I was one of 3 physics majors in my class, so I got a lot of individual attention. And I was very empowered because this is an all-women's school, so there was nothing that I couldn't do in my professors' minds, and that empowered me. My commencement from Emmanuel was celebrated at the Heinz Auditorium. For those of you who know Boston, know that facility. And Barbara Walters was our commencement speaker. And this is a clip from the Boston Herald newspaper reporting on her talk. And her talk resonated with me in one way in particular, and I've got the quote here. So she told us, you really don't have to know now what you're going to do. Decide what you like to do and get some experience. Don't get impatient. And that was very consoling to me because I had no clue what I wanted to do. I had this physics degree, and I didn't want to teach, but I didn't know what to do. So what did I do? I went for more school. And I went to Boston College, which is up the road, not a college, not in Boston, a university in Chestnut Hill, Massachusetts. And it was there that I actually discovered space physics, largely attributable to the man who's pictured here on the right, Robert Carvellano. Bob was a space physicist himself, a magnetospheric physicist, and also the chair of the department. As you may expect, when I went to graduate school, I went into a very different environment. So I went from being at an all-women's school to going into a program where I was the only woman. And many of the men in the program were students who came from Asia and very different cultures, even from the American culture. I really struggled tremendously at the beginning of my my graduate years, mostly because of the culture that I was in and not feeling comfortable. I was very uncomfortable, not confident at all in myself. And so after maybe a year and a half, I went to Professor Carvellano and I said that I was going to quit. And he listened to me and he said, you may not quit. You may take a leave of absence and you go get a job. And if you still want to quit a year from now, then I will allow you to quit. What a great mentor. How insightful was he? And so I went to work in another part of Boston College, actually. It was known as Space Data Analysis Lab. It's now called the Institute for Scientific Research, and there's a big space portfolio of research that's done there. And of course, as Caravellano predicted, I was not enamored with the job I was doing, which was basically coding. And I was more enamored with what my bosses were doing, which was the science. So that was what I needed to motivate myself to go back, and who cares about the men and whether or not they like me, or the professors and whether or not they like me. I need this degree to do what I want to do. So as you can see in the headline here, I was at Boston College working and doing my thesis research for a very long time. And that's because I had several distractions and interruptions along the way, including my marriage and 3 children. So I would take leaves of absence and work as much as I could because I was the primary person responsible for childcare. My husband, who is Jeff Forbes, pictured here when we were young, he had more hair and mine was a darker color. He was the breadwinner in the family, and he also worked at Space Data Analysis Lab at Boston College. That's how I met him. And that's how I became a collaborator with him. We worked together part of the time while I was there. And so anyway, he was extremely supportive and encouraging of me, but he also had to bring home the paycheck so that we could feed our family. One of the other things that's really unusual about my my path and even my degree, my PhD, is I didn't do my research at Boston College. I did my research at MIT Haystack Observatory, which is in Westford, Massachusetts. And I did it under the direction of this man who's pictured here in the upper right, and Dr. William Oliver. And Bill was a terrific mentor and very patient and supportive of me as well, and my interruptions and my slow pace. He is the person who really taught me a lot about the ionosphere thermosphere system. And I was actually studying atmospheric waves under his leadership. I was using the radar data to make determinations of exospheric temperature and looking at the diurnal variability of the exospheric temperature as a function of seasonal and solar cycle, as a function of season rather, and solar cycle. That was my thesis research. Bill moved to BU in the College of Engineering and took a faculty position shortly after I completed my PhD. So I went on to do a postdoc and to become a research staff member at MIT Haystack. And I really collaborated strongly with Joe Salah, who's also pictured here in the lower right part of the frame. And Joe was the director of the observatory. So that was really fortunate for me that I was able to, his scientific interests were near mine, very well aligned with mine. But he had the foresight to, back in the day, and we're talking like the late 80s, to allow me to telecommute. So I had a 300 baud, which doesn't mean anything to some of you, thermal computer terminal that I would use to interact. And I did a lot of work remotely because, as I said, I was still the primary caretaker for our kids. And I would not only telework, but I would go in for meetings and whatever. And he was just terrific. I think if you look at my CV, you can't tell that I worked part-time. So I worked 50% time during those years. And because I just, was highly motivated, and I had the flexibility to do it the way I needed to do it, which was different from most people. So thank you to Joe and to Bill for that part of my career. But everything changed in 1990 when Jeff and I and the kids went to Boulder, Colorado to do a 6-month sabbatical at the National Center for Atmospheric Research. And there I first started interacting with really a profound mentor to me, Ray Roble, who those of you who are in the upper atmosphere research community know as the founding father of the general circulation models of the upper atmosphere, and now WACM, where we have the whole atmosphere model, simulation model. It was Ray's vision that that led to those things. And Ray, for me, was a very intimidating person because I really was not very confident. Those of you who only know me later in my career probably won't believe me, but I was very intimidated by Ray, and it was not about him, it was about me. And because he used to work with his door ajar when he was in his office, and I never wanted to interrupt him. I always felt like I would be imposing myself on him. What a mistake. But anyway, that's how I was in 1990. So I would write little notes to him, and I would have them on my results, and I'd be writing my thoughts on them, and I'd put it in his mailbox, and he would write notes back to me and put it in my mailbox. How inefficient is this? Anyway, I got over that. But
how beautiful, Maura. I love this. It's so beautiful, so poetic. I love it.
But it's the truth, Anyway, we went back to Massachusetts. Jeff at that time was just asked to chair the mechanical and aerospace department at BU. I neglected to say he was a professor at BU after he worked at Space Data Analysis Lab. And I went back to MIT, and then this ad appeared probably in EOS or something like that. And it was for a scientist 1 position at NCAR. And it looked like it was written for me, but so did 125 other people think that. But long story short, they offered me the job. And then Jeff and I took every bit of the 6 weeks that Ray gave me to make up my mind, going back and forth, because Jeff was the breadwinner, as I already said, and a scientist 1 position is the equivalent of an assistant professorship. And Jeff was a full professor, and he was in an engineering school, and this is NCAR. So there was no way I could support the family on this with my job. And BU did their best to retain their shining star. I view him as a shining star. But when the dean took me to lunch and pretty much said, well, name your price, I shared with him that I had applied for 2 faculty positions 2 different times at Boston University, and I was always the bridesmaid, never the bride. And well, once he heard that, then he understood that I got this job at NCAR on my own, and it was important to me that I take that job. So anyway, Jeff took a leave of absence, a 2-year leave of absence, and our plan was that if he didn't find something wonderful in Colorado, that we would go back to Boston, and I would tap dance or something. I don't know what I would do, but anyway, as all of you probably know, Jeff was hired as a professor at the University of Colorado Boulder about a year after we arrived there. And so it was meant to be. We solved the 2-body problem twice in our career, in Boston and in Boulder. And there's not so many places in the world that you could do that. And as I matriculated through the scientific rank, I was asked by various people in leadership at NCAR to take on administrative roles. I was very reluctant at first because I loved my science so much. I didn't want to give it up, but I found that I never gave it up entirely, and that I really enjoyed facilitating other people doing science. And the way I didn't give it up is that I would train students and postdocs and early career people to collaborate with me. And so that way I could live vicariously through their successes and maybe seed some ideas with them. I could not have been successful at NCAR or anywhere without the support of my family, and my husband in particular. When we went to NCAR, he said, "Maura, it's your turn." He understood that I had put my career on hold in order to facilitate his, and he wanted to give back. NCAR would not let me work part-time. Back in the day, in the early 90s, it was all or nothing. I needed to have a full-time job if I wanted to work there. And so Jeff became the person. He had the flexibility as a professor to be able to be more responsible for the kids than me. I had some flexibility at NCAR as well. So I'm very grateful to my son Justin, my daughter Taylor, and my daughter Marissa, in addition to Jeff, for their patience and support throughout my career. So after my foray, I actually served as the deputy director at NCAR for about 6 years, and then I served as interim director for a year. I felt like I had done everything that I could do there, and if I was going to continue to work, that I needed a new intellectual challenge. And I was recruited to come to Utah State and to serve as the dean of the college. The college was in a lot of trouble, and it was my job to try to get it right. I made a commitment of 5 years to, this is the woman who hired me here. This is Noelle Cockett in the middle of the screen. Noelle was the provost and the executive vice president when I was hired. And she subsequently became the president of Utah State University. She was terrific to work with, and she was the first female president of Utah State. She was a real trailblazer herself. And I had a lot of fun doing a lot of very different things. We built a new building, a life sciences building, and I was in charge of making sure that the science was going to be facilitated. This is the Department of Biology. You're talking to a space physicist. So I had a big learning curve, but I had a lot of fun. And I was able to still work with students. And here in the lower left, you can see Mac, who is a young woman who worked with me on the analysis of some Utah State University LIDAR data, looking at atmospheric waves. So I'm paying it forward. I retired in 2021. And so now I have lots of time to spend with family and friends doing things that I like to do. But in addition to that, I'm keeping my hand in the scientific, mostly service work. I serve as the chair of the Association of Universities for Research in Astronomy, which is the equivalent of UCAR on the astronomy side. I serve as the chair. I'm doing a lot of work for the National Academy committee work. I'm serving right now as a panelist for the Space Weather Science and Applications panel for the Decadal Survey. I did a stint consulting as a co-chair on an independent review board for NASA this past summer, and who knows what all else I might do. So life is good, and as I said before, my partner in life, Jeff Forbes, and I made it work. And so that's my circuitous path. And
that's fantastic, Maura. I loved it. And Yeah, you know that the part that I told you that I most love is the little notes to Ray Verbal. You know, because it's also symbolized not only the poetic piece that I like, is, you know, this you allow somebody that is maybe more insecure or more shy writing a note, and he might have, it's not efficient, it's a space to allow you to write, and maybe he honored it, so he write back. And that
Yes,
slowness, I love that not
yes.
everybody is so, you know, forceful and have them. Yeah. The other piece that resonated with me a lot was you talked about, I forgot his name, the professor at
Bob
Boston
Caravano,
College.
probably. Yeah,
Right.
yeah.
I had a similar, and I imagine other people in the audience as well. Me and my sister went to undergrad in physics, and I was thinking to quit every single year. And I had, my dad was a professor, but he would say, just stick one more year, do something else, just give you time, right?
Yeah,
To
that's
and
right.
you might, right. I have some questions, but I would like also to open to the audience to ask Maura. What a beautiful trajectory. I know Nick is helping me moderate. If you have a question, raise your hand or just unmute yourself, or Nick can unmute you and ask directly. While you're thinking, I'm going to start asking one question, but I'm hoping somebody else will take it on. You talked about your Irish, right?
What?
The Irish background
Oh,
that you
yes,
come,
yes, yes.
the Irish. And again, I was thinking, yes, you're an American space scientist, your whole career here, but you come from a home of immigrants.
That's right.
And so, like many people come, but in Boston, the Irish. And I wonder, how do you think this influenced how you were growing up, or maybe there, how the Irish background played in your growing up, or even your thinking as a scientist?
Yes. So it was a very big part of my life, because my mother was an Irish step dancer. Actually, she and her sister were Irish step dancers, and they were part of the Boston Irish culture. Even though they lived outside of the city, they would go into the city for on a weekly basis to be with family, to sing, to dance. When we were kids and we'd go to my grandmother's house for Thanksgiving, and oh, by the way, she would set the table for us. It was just us and Aunt Betty and Uncle Ed. And she had her Irish crystal, her Irish linens, her Irish food. She made turkey too. But anyway, after we would eat, we would push the dining room table to the side, throw back the rugs, and my mother and aunt would step dance for us. And I remember my mother being, you know, out of breath and everything. It was really a great big part of it. So I think how, I'm not sure how it affects my science per se, but it certainly is part of who I am. And
Yeah.
so
Okay.
I was the first
Yeah.
person in our family to get a PhD.
You know, and this is the other aspect that I found amazing. I have students that are first generation, and both the immigrants and both first generation touch on this aspect that you're the first, and you don't have, you know, and on that sense, my dad was an immigrant and a first, but he was an academic. So if I felt insecure, I can call him up. And without that
Yes,
backing,
yes,
you probably have a more insecurity that I have in different aspects, but that is like what I'm supposed to do. And
absolutely.
right.
But as you said in the beginning, you can't be what you can't see. I didn't see myself as an academic until I met Camille Minakino at Boston, at Emmanuel College.
But it's not
And then
just
when
because of the women. Yeah.
yeah, and then I went to Boston College and I didn't see anybody who looked like me at all, ever. Um, And I see somebody is asking whether or not I
Asking, yes.
collaborate with Ann Smith and Rolando Garcia.
Do you want to whoever asks can unmute and ask the questions themselves?
Oh,
Ramesh?
perfect.
Ramesh Karanam, is this you?
They're allowed to talk. They have to unmute themselves.
Okay. Ramesh, can you unmute?
Hello.
Yes, hello.
Yeah, very nice to meet you, MAURA Hagan, because I am a very big fan of her papers on atmospheric tides, as well as time museum. Yeah, did you collaborate with Anne Smith and Rolando at NCAR?
Yes, absolutely. Anna Rolando are terrific scientists, and we have overlapping interests, even though they're in a different laboratory at NCAR. That didn't keep us from interacting. And I can, since this is a personal story, I can also share that. So one of the things that I like to do is to do physical exercise, and so when I became an aerobics instructor when I was still back in Massachusetts, and I brought that skill with me. So I used to teach aerobics at lunchtime at NCAR, and and Anna Rolando would take classes with me.
Fantastic! Oh, I love it! I love it! I love it!
So they like exercise too.
That is fantastic. Great. We have a question from Larissa Goncharenko. If I said your last name, sorry.
Goncharenko, that's right. I know Larissa well.
Yes, Larissa, do you? Yeah.
Yes, I just unmuted myself. Thank you so much. So, Maura, first, thank you so much for all these absolutely amazing stories and your life path. It's I find it really inspiring. Really can appreciate all these all the difficulties that we face as scientists and working mothers. And how it can be difficult with two careers. And I actually was when I signed up for a webinar, I was expecting to hear more about atmospheric waves and science, but I'm really appreciate your personal story. So my question to you. I always admired your work on advocating for the roles of waves, roles of low atmospheric forcing in the entire geospace system. And your contributions are absolutely outstanding. Your contributions and Jeff's contributions are absolutely fundamental for our field. And I kind of was searching for some words of wisdom. What can you advise how to advocate better for our science, for visibility of our science, and for the future? Because I am not quite satisfied with what we see in our field, in particular in ionosphere, thermosphere. And I have a lot of concerns about it. So was wondering if you can share some words of wisdom.
Well, thanks, Larissa, and I appreciate your compliments, but you have carried the torch in this regard for a very long time, and your work on waves in the middle and upper atmosphere is outstanding. And so keep up that work and keep up that advocacy, both in the CDARC community and beyond. I think you've done it, and I think others have done it in writing white papers to the decadal. This is the best way to make sure that the science that is important to us is brought forward as in the form of recommendations to not only the agencies, but to Congress and the President. I do share your concerns, particularly with the disposition of the geospace dynamics constellation and the
Yes.
pause that we're seeing. Actually, the IRB that I did for NASA this past summer was for GDC. And we did our best to do an independent analysis, but to underscore just how important that mission is for space weather.
Absolutely.
If you've seen El Sayed Talat talk at all about the new office that's in Nesdis at NOAA, I think they're calling it the Space Weather Office now. They're relying on GDC measurements for their part of the mission. And as you well know, you need the dynamic component, the other mission, in tandem with GDC in order to be able to ensure that you account for the wave forcing, which is extremely important to space weather. So I think
we might have you come to talk to SHIELD, because I have a student working on it now. We are trying to understand the impact of different environments in the heliosphere to the thermosphere. So
so I would say, you know, when you're asked to serve on national committees and when you're asked to provide input, do it. Be proactive. What about you, Marab? Do you have any other advice in those regards for advocacy?
Yes, you know, I serve in one of the latest committees that MAURA was co-chairing, and I was a member. And it's hard in a sense when, you know, when I start, now I am full professor, but when I was starting as an assistant, and my kid now is 13, but they were younger, and it was very tough juggling. And I was divorced, so there was a whole personal parts of trying to juggle your career. And then when people will will ask me to serve, my instinct was always to say yes. I think this advocacy is so critical, but juggling all the pressures are hard. I tend to always try to squeeze in and do, because I think this service is critical.
Yeah.
Also for you, it's a big discussion when you are also in an underrepresentative group. You get to ask to serve in more committees, and you came into the field to do science, and so it's a really burden on underrepresentative to sit. But I am with Maura on that. It's so important to voice, and NASA does listen, and other does listen. They do listen, but it's a really hard.
You raise a very important point, Marab, and when I have been mentoring young people, I have always encouraged them to say yes selectively and no graciously, because you never want to burn a bridge, but you do have to think about what your own personal goals are, particularly when you are an underrepresented
and you don't want,
minority.
and I hear what you said, Maura, and then we will pass to the next question. Your personal life is so critical. It's so critical. That time with the kids, it doesn't come back. Time with the partner doesn't come back. So having that very strong support is critical. So you don't want to burn the bridges. You don't want to be over. I agree with you on that.
If you're not a happy person, you can't be a good scientist. You have to have other things in your life.
Your base, your happy base needs to be there, especially because out there can be challenging. You want to come back to your warm and happy place.
That's right.
I agree with you totally. Judy, Judy Coffin had another question. You want to unmute?
I'm Maura.
Opa, did you fail? Judy disappeared.
I screwed up. I'll get her back.
Okay.
Have Judy back here. And Larissa, it's my fault that Maura didn't talk about science, because I asked her to talk about your career, and you had such an amazing story that I was so delighted.
Well, it's certainly non-traditional, right?
I think Judy's back. You can unmute, Judy.
Sorry, it just made me become a panelist. That's kind of scary.
Not for you, Judy. Come on.
Yeah. So hi, Merav and Maura. It's a pleasure to see both of you. I had a somewhat silly question, but it's something I've been thinking about probably my whole life. A really large fraction of the women that I know who are in science or first children, the oldest. And this is a totally anecdotal, I ask people and that's that they tell me. But I was wondering whether you think that may have had anything to do with your ability to forge ahead and, get on the path that you did.
I think it's a very interesting observation and a very interesting question, Judy. Well, certainly my parents expected a lot of me. They would say, you have a fine mind and you need to, they didn't encourage me to think about what I wanted to be when I grow up. But they did expect me to do well in school and they expected me to go to college. And I don't think they had any clue of what I was interested in either, but I was definitely took on a lot of responsibilities in the house too. So you probably saw the picture of my family with my Irish cousins in the first couple of slides. And my youngest brother was 14 years younger than me. So I did a lot of childcare and I had a lot of responsibility for my poor mother, her taxi service was handed on to me once I could drive, and so I would take the family skiing and I just had a lot of responsibility and they thought I was capable. So they did instill in me confidence that I could do whatever I wanted. I didn't always get it from other sources.
Yeah.
But I'm guessing that must have played a role in allowing me to, especially when I decided that I wanted to do the PhD, to just go back with a vengeance, put that nose down. I don't care what people are saying to me or.
I think it's so interesting too. We can have a whole webinar and discussion or a panel one time. What give you this inner confidence that you come back with a vengeance? You really stick to it.
Yeah.
And if I think I asked you this more before. What was the role? If this is a family, really, right? Sorry.
Say that again.
If this is something in your family that really, give you that confidence.
That's right. That's right.
I think
my husband played a big part also, especially, as I told you when I was on the sabbatical and I'm writing the notes to Ray Robel and so forth. And even when I was applying for the job at NCAR, we used to talk about having Haganitis. So Haganitis is when you don't feel confident in yourself, when you think the rest of the world is better than you. And he really would say to me, well, nobody's going to do that for you. You need to do it for yourself, kind of thing, and so he was very empowering.
Great.
He's an only child. He had all the confidence that I didn't have. But only children also, I think, are tend to excel.
My sister had the theory that women that have dads that were scientists, that they send you back. So I don't know. This is an interesting discussion.
Yeah, I can think of several. Clara Dessa from NCAR, who was recently elected to the National Academy, I think maybe a year or so ago. Her dad is also a member of the National Academy.
Right, interesting. Yeah. Very good. Folks, we are almost at the top of the hour. We need to close. Anybody has a final question or remark tomorrow? That was so delightful. I will keep the notes that you keep sending back and forth in my, I love the images. It's so beautiful. Oh God, Holly said, thank you so much. Yes, Stanley, Nick, did you guys have, those are I forgot to present you guys. Those are my amazing Broader Impact. Stanley Buckner is the director of the Broader Impact and Nick Ross is the deputy. They're amazing. I'm
Well,
really
and we
sorry I didn't present you.
corresponded, and they were very helpful to me.
They
So
were
thank you.
fantastic. I love
Yeah.
them.
Maura, I just wanted to say, Maura, like I just loved your story and just the humanity that you presented. And I think that was so fantastic. So thank
Oh,
you.
great.
Yes.
Great. It's kind of fun to talk about yourself.
No, but you know, Maura,
Fun and
this-
funny.
no, but how many chances you have, right, to hear the
Right.
stories?
Oh, no.
And it's, yeah.
And I hope that the fact that I had a non-traditional path, you know, empowers others who maybe don't know exactly what they want to do right now to explore what interests them and to discover.
I love the notes that we read about Barbara Walters.
Yeah,
You don't
yeah.
have to, you know, yeah, that is also fantastic.
It's
I
a
love it.
process. Yeah. Anyway, thanks again, Marav, and thank you all for your attention.
Thank you
today.
so much, folks. It was lovely, lovely, lovely. And see you in May, not in April, sorry, for with Psycho PI. Very excited. Okay.
Bye-bye.
Bye. Bye.